Hey, time for your life's math industry, and we are going to take a look at composite algebra functions. So this is going to be a review video because it's nearing the end of trimester 1 for pre-calculus. And when we go into the next trimester, we have to kind of go back onto the algebra basis and kind of recharge of what we know. So in this one, we're going to take a look at composite algebra functions. So right over here is a composite function. And the crazy thing is, we do know that whatever you put in for x is going to get you to your letter f, which is an input and an output. But composite functions have at least two or more functions that are meshed together. So what happens is, if you want to find x, and if you want to insert something at x, but to get something out of f, you have to do the g of x first, then that answer, you'd have to bring it to your f of x. So what happens is, when you do composite algebra functions, your math teacher is going to actually give you values for each of the functions, so you know what's going to happen and when. So right over here are some examples. So if the function of x equals 2x minus 1, and the function of gx equals x squared plus 3x plus 4, then what's going to happen? So we need to do something. We need to come up with some problems that will help us out. Right over here is actually the problem. Well, problem solved that we now have a problem, but the problem is now solving the math. Okay, so if we have the information given right here, then the directions here, f plus g as functions in parentheses of x, what's going to happen? Well, we know we have an f and a g, and we know that these two functions are going to be added together. So what's going to happen is we have 2x minus 1, but then we add that by x squared plus 3x plus 4. So we get a final answer of x squared, because it's alone. Then we have to add by 5x, and then we have to minus that by 3. But wait, there is a mistake. We have a 2x and a 3. There is no mistake, so we're okay. It's a good idea to check over, because you might miss a simple step such as operation sign. So that's why we wanted you to think we made a mistake, but in reality we haven't. So what actually happened is, about this composite function, we have two of the functions added together to get this new equation, or this new expression right here. Its domain is going to be negative infinity to positive infinity, because it's a quadratic. And if you try to graph it, you'll have negative infinity number of x values and positive infinity number of x values. Let's try another problem. So right over here is another problem. So instead of adding the two fractions, it's saying that there's this tiny dot right in between the f and the g function. So that tiny dot means you're trying to multiply both other functions together. So what's happening is you have 2x minus 1, because that is your f function. Your g function is going to be x squared plus 3x plus 4. I just added that tiny dot because we know that we're multiplying, but you don't need to add anything in between each other, because parentheses together automatically means you're multiplying something. So what we have to do is FOIL it out. We have to do this times this times this times that, and this times this times this. And when you do that and you FOIL it out, you are going to get 2x and x squared is 2x squared. 2x times 3x is going to be, 2x times x squared is going to be 2x to the power of 3. 2x and 3x is going to be 6x squared. And with 2x and 4 is going to be 8x. Minus 1 and x squared is going to be negative x squared. Minus 1 and 3x is minus 3x. And then we have minus 1 and 4, which is going to be negative 4. So now we got to combine the like terms. 2x to the power of 3 plus 4x squared, because we did this and that, plus 5x, and this is minus by 4. So this is our final form of what's going to happen. So that is going to happen when you multiply these two together. And it still has a domain of negative infinity and positive infinity. Let's take a look at one more problem. So right over here is we have the function of the function of f of the function of x equals x. Imagine if it was like the function of f of 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 the function of f. That would be really funny. But going back to the actual problem, it's saying that we have to multiply these two in the same idea. But the thing is, we have to put the function inside of the function. So, you know how the function of x is going to equal 2x minus 1? Well, when you put the function inside of the function, what's really happening is you're saying 2 parentheses 2x minus 1 parentheses minus 1. So what's actually happening is this is just one function, and this is actually the other function inside of that one. Alright, so let's actually solve it out. 2 and 2x is 4x, and 2 minus 1 is negative 2, but then we have the minus 1, so negative 2 plus negative 1, so we get 4x minus 3 as our final expression answer. And it's still as a domain because it's a linear slope, negative infinity and positive infinity. So that is how we can review the composite algebra functions. When you want to put more than one function, when you want to put x into more than one function to get an answer at the same time. All at once. I hope this video has helped you understand reviewing composite algebra functions. Thank you for watching Tao Fingerline's Math Industry. Like and subscribe.